Okay, today we're going to be looking at solving equations that contain a square root. And we know that the opposite of a square root would be to square a number. So we're going to continue solving using inverse operations. And when we have to undo the square root, we're going to square it so that we can end up with the variable by itself. All right, so looking here, we're going to go through all of our steps for solving just like we normally would. So we're trying to isolate that x, and we're going to start by subtracting 5 on both sides. So we have the square root of x is equal 13 minus 5 is 8. Then we would undo the square root by squaring both sides. So the square of the square root of x is x, and 8 squared is 64. Okay, next one. Notice there's a negative in front, so we'll deal with that in just a little bit. We're going to go ahead and we're going to add the square root of x to both sides. So now we have 3 equals the square root of x. We're going to square both sides of the equation. So we have 9 equals x. Now we can see our equations are getting more complicated. So again, we just want to follow inverse operations just like we would as if there wasn't a square root. So the first thing we want to get rid of is that addition. So we're going to subtract 3 on both sides. So we have 4 times the square root of x plus 2 equals 16. Then we need to get rid of the multiplication. So we're going to divide both sides by 4. So we have the square root of x plus 2 equals 4. Then we need to get rid of the square root. So we're going to square both sides. So we have x plus 2 equals 16. 4 times 4 is 16. Then we're going to subtract 2, and we have x equals 14. Okay, we're going to try one that now has a square root on both sides. So same idea, we're going to square both sides of the equation. So we end up with 2x minus 1 equals x plus 4. Now we have variables on both sides, so we're going to subtract x. So we have x minus 1 equals 4. Then we're going to add 1 to both sides, so x equals 5. We're going to talk about something called an extraneous solution. So this is when we solve our equation, but when we plug it back in, it actually doesn't work. And so we want to make sure that we're paying attention to that. And that happens sometimes when we have two solutions. So notice here that we have variables on both sides, but only one of the variables is underneath a square root. So we're still going to square both sides. So we have x squared equals x plus 6. Okay. Now we're going to go ahead and solve, and we're kind of thinking back to our trinomials. We're going to get all of our terms on the same side. So we're going to subtract our x, and we're going to subtract our 6. So we end up with x squared minus x minus 6 equals 0. Then we want to go ahead and factor. So we would end up with x minus 3 times x plus 2 equals 0. And we have two solutions, right? We're going to set both of these equal to 0. So we have x minus 3 equals 0. So x equals 3. And we have x plus 2 equals 0. So x equals negative 2. Okay, now we want to just make sure that both solutions work. Because we have more than one solution, we want to plug them back into our equation and just confirm that they work. So we have x equals the square root of x plus 6. So we have 3 equals the square root of 3 plus 6. 3 plus 6 is 9. And the square root of 9 is 3. So we know for sure that x equals 3 is a solution. Okay, we're going to check our other solution. So we're going to plug that in. X equals the square root of x plus 6. So negative 2 equals the square root of negative 2 plus 6. So negative 2 equals the square root of 4. Negative 2 equals positive 2. Ooh, right here, this is not true. Negative 2 does not equal positive 2. So that tells us that there's really only one solution, x equals 3. That this second solution that we found is an extraneous solution. That means it's actually not a solution. It was produced when we factored, but it's not a true solution to the equation.